Hello students, this is SAHA tutorial now, and today's topic is Volterra integral equation. I provide an example here and discuss about Volterra integral equation with given kernel, and we have to uh, find out the result. So first subscribe this channel. I appeal to all of you. First subscribe this channel. If you like videos, then like, share it with friends, and comment me. So let's start. There is the given that alternative the kernel is given that kernel is given that this is done by e to the power exponential function e to the power x minus t, and we have to find out the resultant. We have to find out the resultant r x t and lambda. So we have to find out this. Let's start the problem to find out the resultant of this exponential function e to the power x minus t. So we have a formula to find out the resultant. The formula is the formula is for nth number of successive kernel ANXT is equal to integration from t to x, ultra type k xj into k n minus 1 z, and this is the integration with respect to dz. Here n can be n is equal to 2 3, and there are 2 3 4 there are, so this is the formula. And here also k1 is k1 xt is equal to this is applicable for 2 3 4, and k1 is equal to the kernel given k1 xt is equal to kxt. So in this way we have to find out the all these kernels, and then we will use the formula of resultant. I am not giving now. I will give you later that what is the formula of the resultant. So we have to find out the all the successive kernels first. So we have to remember that our exponential function is e to the power x minus t. Let's start. So first kernel k1 xt will be the given kernel e to the power x minus t. Then we have to find out k2xt by the formula that I have provided within this. To find out, it will be integration of t2x and kxt. It will be to the power x minus t, and k to the power n minus 1. K to the here n is equal to 2, so we will get n minus 1 means k1 xt. So it will be e to the power x minus t. Then sorry, k to the power xz. This is getting wrongly. Actually, here will be k xz, and then will be n minus 1 means 2 minus 1 1 k1 zt. dz. So if we put, then we will get t x, and this will be e to the power x minus z. There will be also e to the power z minus t dz. So we don't need to calculate e to the power x and e to the power minus t. We will take out from the integration e to the power x minus t out of the integration, and then integrate t to x e to the power. This will be 0, e to the power z minus z, it will be 0. This is that's why there will be 1, and we will get integrated. There will be z means x minus t. So you will get e to the power x minus t, and we will get uh, x minus t. First bracket. So this is our second kernel. First kernel this is, second kernel this is. So we have to now find out the third kernel. I am writing here all the kernels. K2 we have found out. K2 we have found out. E to the power x minus t. Then we will have to find out the third kernel. The third kernel will be calculated this way. K3 x3 will be integration of t2x kxz and kn minus 1 means 3 minus 1 2. So k2 zt respect to dz. So you have to put this value. We have already found out k2. So we'll put this t x kxz. We know this is equal to e to the power k1 xt. So this will be e to the power x minus and k2 also I found out. This is equal to this to the x minus t into x minus t. So we have to just change in place of k x, there will be z just e to the power z minus t into z minus t dz. So again, from the two first terms, you will get e to the power x minus t, z will vanish. So we will get so and e to the power x minus t is a constant. So you can take out this x minus t. So we have to integrate just t to z minus t dz. This is very easy to integrate. It will be equal to e to the power x minus t into this will be z minus t whole square by 2. And we have to put these values, these terms. So this will be z minus t by 2 from t to x. So if we put this x and t, then we will get k3 will get k3 will be k3 xt will be e to the power x minus t, and here if we put x, then x minus t, there will be whole square not given. There will be a whole square also. Z minus t whole square, z minus t whole square by 2, not this. Z minus t whole square by 2 from 2 to x. So this will be x minus t, and we will put z equal to x minus t whole square by 2 and minus t when we will put, we will get 0. So this will not, we will put. And in this way, we will have to find out the fourth kernel also. This was our third kernel. We find out the fourth kernel k4 xt, and now you have already understood how I am putting. I am directly putting all these values. T x, here will be e to the power x minus z, x minus z, and here will be e to the power z minus t, and integration of this z minus t by 2, sorry, z minus 2, z minus t whole square by 2 with respect to dz. One thing is to be noticed that this will always give you e to the power x minus t, and all this integration you will get factorial here. You will get factorial. Here we will get what? 3 factorial. Here we have obtained 2 factorial. This 2 factorial value is 2. Here we will get obtain 1 factorial. Here we will have 0 factorial. So when we will integrate this, so we will get easily e to the power x minus t out of this form, and that this limit also works as just for x, not for t. For t is equal to 0. So when we will put x, it will be x minus t, and when integrate it, it will be q, and we will get one more element 3. So in this way continuously, if continue, then we will get x minus t whole cube, and I will get 3 into 2 means 3 factorial. So if we calculate k nth term, this is fourth. If we calculate fourth nth successive derivative of the kernel, what we will get? Kn xt will get e to the power constant e to the power x minus t for all the kernels, and here is some change that it will be x minus t to the power n minus 1, and below we will get n minus 1 factorial. We have noticed that in this way all the kernels are found out. So this is the nth number of kernel. So what will be now resultant? Resultant are xt lambda t lambda is equal to summation of m is equal to 1 to infinity lambda m into k to the power m xt. So if we know n number of kernels, then you can already you can very easily find out the n number of kernel also. All follows a certain rule x km x minus t xt. So if we put all these values here, all these values here in this European kernel, then we will get we have a summation also. So m is equal to 1. So we will get 1 means lambda. There will be this is m minus 1. Sorry, there will be 1. This will be m minus 1. Lambda m to the power m minus 1. Lambda to the power m minus 1. So we will get lambda 0. If we expand the series, then we will get lambda 0 k1 xt, and this way we will get the second term lambda 1 k2 xt, and then we will get lambda 2 square k3 xt, and so on. So we will get all these terms. So there are infinite number of terms. So here we will get just k1 xt is equal to e to the power x minus t, and there is lambda, and we have obtained e to the k2 xt e to the power x minus t into x minus t. Then we have obtained the third kernel, and here lambda square. Third kernel is e to the power x minus t, x minus t whole square by 2. Factorial I am giving 2 factorial is equal to 2. The fourth kernel is in this way we have obtained lambda k. The fourth term will be lambda k e to the power x minus t, and then x minus t whole cube by 3 factorial, and it continues to be. So it is possible now to sum this series. It has a it is now in geometric progression. So we need to just find out the common ratio. So I'm now taking the uh, common part. Common part is that e to the power x minus t. If you take common, then it is easy to find out all the terms. We'll take, then we will get 1 plus lambda x minus t plus lambda square x minus t whole square by 2 factorial, or all 2 factorial, and in this way the third term. So it is a geometric progression, and there is a not a geometric progression, sorry for this, there is a factorial, not it is a geometric progression, but it is a exponential series. You can put here 1 factorial, and here you can put that it is equal to lambda 0 and x to the power minus t to the power 0 by 0 factorial. It is exponential, sorry for this, not geometric progression. I have not noticed that there is factorial. So exponential series, it will be e to the power x minus t, and also e to the power lambda x minus t, e to the power lambda x minus t. If we sum the powers for the exponential, then we will get e to the power 1 plus lambda and x minus t. So this is our resolvent kernel to for this Volterra integral equation. I hope you understand this topic, and in this way you can find out another problems also. So must do from a book, from integral equation, higher order integral equation, Volterra and Fredholm equation, must solve. And if you have any problem, then comment me. So thanks for watching.